Imagine witnessing the birth of a star, a celestial event of unimaginable power and beauty, a moment of creation captured in the vast expanse of cosmic time, or walking among dinosaurs, feeling the earth tremble beneath the feet of giants, experiencing a world lost to us for millions of years, a world teeming with life, a vibrant ecosystem that existed long before our time. Time travel promises journeys, adventures that transcend the limitations of our present moment. Not just through space to distant galaxies and unexplored planets, but through time itself, to eras long past and futures yet to be written. This idea has fascinated humanity for centuries, sparking our curiosity and igniting our imaginations, fueling myths, legends of gods and heroes who could manipulate time, bending it to their will, philosophies, pondering the nature of time, its flow, its mysteries, and its profound impact on our existence. And our favorite stories, tales of daring adventurers who dared to defy the constraints of time, exploring the past, present, and future. We're all travelers through time, whether we realize it or not, constantly moving forward on the river of time. Moving relentlessly forward with every heartbeat, each tick of the clock marking our journey through the seconds, minutes, and years. But what if we could pause, suspend ourselves in a single moment, savoring it for eternity? Rewind or fast-forward our existence, to relive cherished memories or glimpse the possibilities that lie ahead. What if time was a landscape, not just a measurement, but a vast and varied terrain to be explored? Science fiction gave us the time machine, a vessel to explore history, to witness pivotal moments firsthand, and speculate about the future, imagining the wonders and challenges that await us. These stories are more than entertainment. They are a reflection of our deepest desires and anxieties. They're thought experiments about causality and consequence, exploring the potential ramifications of altering the past or influencing the future. But is time travel just fiction, a fanciful dream confined to the realm of imagination? Science has its own story, a narrative built on rigorous experimentation and careful observation. Written in mathematics and confirmed by observation, a story that challenges our intuitive understanding of time and space. Time isn't constant, it's not a fixed and immutable entity. It's woven with space into space-time, a flexible fabric that can be warped and bent by gravity and motion. Einstein's theories show with compelling mathematical precision that time travel to the future is not only possible, but an observed fact, a consequence of the laws of physics that govern our universe. The past, however, remains a far more mysterious and challenging frontier, shrouded in uncertainty and paradox. Our journey begins with the dream of traversing time, a dream that has captivated humanity for generations. A dream that science is only beginning to unravel, to explore the possibilities and confront the challenges that lie ahead. Let's explore how this dream has shaped our understanding of the universe, and what the latest scientific discoveries reveal about the nature of time itself. Long before complex equations filled chalkboards and scientific theories took hold, ancient stories, whispered around campfires and etched onto temple walls, played with the very essence and flow of time. These weren't just simple narratives, they were profound explorations of what time be, bending and shaping it to explore the human condition. Consider, for instance, the Hindu myth where King Raivata, seeking counsel, makes a pilgrimage to Brahma's celestial realm, a place beyond earthly constraints. He spends what feels to him like only fleeting moments in divine conversation, only to return to his kingdom and find that ages, entire epochs, have irrevocably passed. The world he knew is gone, replaced by something utterly unfamiliar. Similarly, Japanese legend tells the poignant tale of Urashima Taro, a fisherman who, in a moment of kindness, is invited to spend what he believes to be 3 blissful days in an opulent underwater palace, but returns to the surface to find his village transformed, his loved ones gone, and the world 3 centuries older, leaving him utterly alone. And then, there are the timeless stories of the 7 sleepers of Ephesus, a narrative found woven into both Christian and Islamic texts, who seek refuge in a cave and fall into a deep enchanted sleep that lasts for centuries, awakening to a world utterly transformed, a society unrecognizable from the one they left behind. These tales, though fantastical, subtly hint at time's inherent flexibility, its capacity to stretch, compress, and even seemingly stand still. They represent an early, intuitive grasp of what we now understand as time dilation, the concept that time's passage is not uniform, but relative. Crucially, these stories aren't typically about the mechanics of traveling to the past and altering events. but rather about the profound consequences of leaping into the future, often unintentionally. They are explorations of loss, alienation, and the disorienting experience of being disconnected from one's own time. Though steeped in magic and myth, these narratives serve as the philosophical ancestors of modern time travel stories, fundamentally asking the question, what if we could somehow step outside the normal linear flow of events and witness the unfolding of time from a different perspective? In essence, they laid the crucial groundwork, planting the seeds of curiosity for the scientific and literary explorations of time travel that were yet to come. Our enduring fascination with time's deepest mysteries, its paradoxes, and its potential manipulations is as old as storytelling itself, a testament to humanity's boundless curiosity. With the industrial age, time travel stories shifted from magic to machines. H.G. Wells' The Time Machine made the concept iconic, using technology to explore the future and critique society. Time machines became a staple of science fiction, moving the genre from fantasy to speculative science. Modern stories, from Doctor Who to Back to the Future, use time travel for adventure, comedy, and deep philosophical questions. Fiction lets us grapple with paradoxes like the grandfather and bootstrap paradoxes, making complex physics accessible. These stories are public forums for exploring the consequences of changing the past or glimpsing the future. Through narrative, we make sense of time's mysteries and our place within them. Storytelling bridges the gap between abstract theory and human experience. Science fiction often treats travel to the past and future as equal possibilities, showcasing fantastical devices and daring adventures. We see heroes jumping between eras with apparent ease, rewriting history or glimpsing potential futures. But the reality, as described by physics, draws a sharp line between these two concepts. The laws governing our universe treat forward and backward time travel very differently. Traveling into the future is not just a theoretical possibility, it's a real phenomenon, proven by Einstein's theory of relativity. This groundbreaking theory revolutionized our understanding of space and time. Time, according to Einstein, is relative. It doesn't flow at a constant rate for everyone. Its passage is influenced by both speed and gravity, creating a dynamic and interconnected space-time. The faster you move through space, the slower you age relative to those who are at rest, or moving at a slower speed. This isn't just a theoretical concept, it has measurable effects. This phenomenon is known as time dilation, a direct consequence of the principles of relativity. It demonstrates that time is not absolute, but is instead a flexible dimension. Imagine astronauts embarking on a journey at near light speed. Upon their return, they would be significantly younger than their Earth-bound twins, who experience time at a slower rate. This effect isn't just a thought experiment, it's a real, measurable phenomenon that scientists have observed and verified through experimentation. For example, atomic clocks flown on airplanes run ever so slightly slower than identical clocks on the ground, precisely matching the predictions of relativity. The Global Positioning System, GPS, relies on a network of satellites. These satellites must constantly account for the effects of time dilation to provide accurate location data. Gravity also warps time, creating another avenue for experiencing time differently. The stronger the gravitational field, the more time is affected. Stronger gravity means slower time. An object in a high-gravity environment will experience time at a slower pace than an object in a low-gravity environment. Near a black hole, where gravity is incredibly intense, time slows down dramatically compared to the experience of distant observers far away from its pull. Therefore, the universe itself provides us with the mechanisms for traveling into the future, even if we don't yet have the technology to fully exploit them. However, it's crucial to remember that this journey is, as far as we understand, a one-way trip. There's no known way to reverse the process and return to the past. In a very real sense, we're all time travelers, constantly moving forward in time, albeit at slightly different rates depending on our individual journeys through space and the gravitational fields we encounter. The dream of leaping centuries ahead, of witnessing the future unfold, is therefore real in principle, grounded in the established laws of physics. However, the practical application of these principles, the development of technology capable of achieving significant time dilation, is not yet within our grasp. The past, with all its mysteries and untold stories, however, remains elusive, locked away behind a barrier that physics seems unwilling to yield. Traveling to the past is where science enters speculation. General relativity allows for closed time-like curves, paths that loop back in time. Wormholes, or Einstein-Rosen bridges, are hypothetical shortcuts through space-time that could connect different times. To keep a wormhole open, we'd need exotic matter with negative energy, something never observed in usable amounts. Other ideas, like Tipler cylinders or cosmic strings, require conditions that seem impossible. Most physicists believe these structures would collapse instantly or can't exist at all. The universe's equations leave the door to the past slightly open, but reality may keep it locked. For now, backward time travel remains a tantalizing but likely unreachable dream. Time travel to the past opens a Pandora's box of paradoxes. Presentism says only the present is real, making past travel impossible. Eternalism, in line with Einstein, sees all moments as equally real. If the past exists, could we visit it? This raises questions about free will and destiny. The bootstrap paradox asks, if a time traveler gives Beethoven's music to the past, who composed it? Objects or information can exist in a loop, with no clear origin. These paradoxes challenge our understanding of causality and creation. Another example, a watch endlessly passed between past and future, never manufactured. Such puzzles aren't just fun. They're serious challenges for any theory that allows backward time travel. They force us to question whether our universe permits such loops, or if our logic is incomplete. The answers remain elusive, fueling both science and fiction. The grandfather paradox asks, what if you went back and prevented your own existence? This contradiction suggests changing the past may be impossible. The Novikov self-consistency principle says the universe forbids paradoxes. Events must be consistent with history. If you tried to change the past, something would always stop you. Quantum mechanics offers another solution, the many worlds interpretation. Changing the past creates a new timeline, leaving the original unchanged. You'd be stranded in a parallel universe, not altering your own history. This idea inspires stories of alternate realities and branching possibilities. Whether the universe is self-correcting or infinitely branching is still unknown. Until we can test it, the question remains one of science's greatest mysteries. If time travel to the past is possible, where are the visitors from the future? Despite speculation, there's no credible evidence of time travelers among us. Stephen Hawking famously hosted a party for time travelers. No one came. This absence is called the Fermi paradox of time travel. Maybe backward travel is impossible, or only possible from the moment the first time machine is built. Perhaps time travelers are hidden, or every trip creates a new universe, so we never meet them. The silence from the future leaves us wondering if we're truly alone in our moment. For now, we wait, listening for echoes from tomorrow. Time travel is more than a puzzle, it's a mirror for our hopes and fears. From ancient myths to modern science, our quest to master time reveals the universe's strangeness and wonder. Forward time travel is real astronauts return younger than if they'd stayed on Earth. The past, though, remains shrouded in paradox and mystery. Yet our fascination endures, inspiring scientists and storytellers alike. These stories let us explore history, imagine the future, and ponder the weight of our choices. Time travel encourages us to think big, to see our lives as part of a vast cosmic story. Whether or not we ever build a time machine, the journey to understand time is a profound adventure. And that journey, perhaps, is the greatest voyage of all.